So let's look at some examples. So we're going to first do examples by the DISC method that you looked at in the explanatory videos. So we're asked to find the volume of the solids generated by the revolving the regions bounded by the graphs of the equations about the given lines. So our first one, the equations they're going to give us is y equal 2x squared, y equals 0, x equal 2. And we want to do around the x-axis and the y-axis. So you can graph it in your calculator unless it's a non-calculator portion. And so you can just look at it on your calculator or you can sketch it. I sketched it so we can talk about it. So y equal 2x squared is going to be this part of the parabola. And x equal 2 is going to be a vertical line. And so we're talking about that, and y equals 0 obviously is the x-axis. So we're talking about this shaded region. So in part A, we want to go around the x-axis. So remember, you make a little slice of a rectangle that is perpendicular to what you're rotating around. So this is our little slice. And then we're going to integrate, so that'll take all the multitudes of rectangles that we would have. Now, remember volume is pi r squared h. So what we have is we have our pi that we put on the outside of our integral. And then we're going to get our radius, because remember when it goes around, it's going to look like that. It's going to look like a disc. So we're going to do our radius, the length from where we're revolving to our function. And then our height is the width, the change in x, which in our formula will be d of x. So our radius then is going to be our function. So we just have pi r squared, and our height is d of x. So if we were on a non-calculator part, we could do this. So that would be 4x to the 4th. And then when we use our power rule and evaluate, we get 25.6 pi units cubed. Now, sometimes you will see the pi, the numeric value of pi multiplied by that, and sometimes you won't. So just have to look at your multiple choice answer. If it's on a free response, they'll take either one. So let's look at part B. Okay. So part B, we have the same graph, but we want to go about the y-axis. So remember, we're going to make a horizontal, and we'll be going this way. So our radius is the length from the y-axis to here, which would be our function. But because we're going on the y-axis, we have to have y bounds, and we also have to have an x equal equation. So you know that you had an x equal 2 lines. So if you plug 2 into y equal 2x squared, you're going to get 8. So if you plug 0 in, then obviously you're going to have 0. So your bounds are 0 to 8. Now we have to convert this to an x equal equation. So I'm going to divide by 2 or multiply by 1/2, whichever way you want to think about it. And I'm going to do the square root. Now I'm only doing the positive square root because remember we were bounded by y equals 0, so we're in the first quadrant. So then my radius will be this. So I go pi r squared dy is my height. And so when I work that out, I'm going to get 6 pi units cubed. Now let's try another example, and you can follow along on your pass out. So we want to find the volume of the solid formed by revolving the region bounded by the graph of f of x equal to the square root of sine x, and the x-axis, and just between 0 and pi, about the x-axis. So if you sketch it in your calculator and you sketch it on your paper, it's going to look like this. We're going about the x-axis, so we're doing a perpendicular rectangle. Again, our radius is the value of the function. So we're going from 0 to pi. So we got pi, our bounds are 0 to pi on the x-axis. Our radius is the height, which is the function, square root of sine x squared. well, that's our radius, not our height, and then our height is dx. So then when we do that, if you did this manually, the square and the square root are going to cancel out. And so the integral of sine is negative cosine. And when we plug those values in, we get 2 pi units cubed. Now, let's look at this next one. Okay, so we're going to find the volume of the solid generated by revolving the plane region bounded by the equations about the indicated lines. So this time we got an x equal 1 minus y squared and the y-axis, which is x equals 0. And I don't think I wrote it here, but we're asked to revolve around the y-axis. So you see how I've got my arrow drawn there. So, to go to the y-axis, first of all, we got to see what our intersections are. So, we're going to set 1 minus y squared equal to 0. And if you solve that, you get y plus or minus 1. So, you're going to take the part of the function from here to here. Now, up here, if it was a non-calculator part, you would just solve for y so that you could sketch it and understand it better. Or even if it is a calculator part, you've got to get it in y equals so that you could look at it in the calculator. So that's all this was solving this for y. So you got the positive and the negative of each of those. All right, so we know we've got this region then. We're going about the y-axis, so we're going to use negative 1 to 1. And we've already got our x equal equations. So we're just going to do pi negative 1 to 1, 1 minus y squared dy. And then if this was a non-calculator part, you would FOIL this out. Then you would use your power rule and evaluate. And you're going to get 16 over 15 pi, or if it's on a calculator part, it'll be 1.067 pi. Now we're going to do some examples of the Washer method. And the Washer method just means that you're going to have two functions. So remember from the instructional videos, it's going to look like a disc, but it's going to have a hole in it. So that's where it gets the name Washer. So we got find the volume of the solids generated by revolving the region bounded by the graphs of the equations about the given line. And we're given the function y equals 6 minus 2x minus x squared. And we have our other equation y equals x plus 6. And we're going around the x-axis. So you can graph it in your calculator and find your intersection points. And then I sketched it here. So if you find your intersection points in your calculator, it's going to intersect at 0, 6, and it's going to intersect at negative 3, 3. So we're talking about this little region in here. And we're going around the x-axis. So think about when we talk about our radius. Our radius is going to be, our big radius is going to be all the way to the top. And then our small radius is going to go to the bottom. And then when you subtract, you'll have the radius there. Let me say it again. So you go from here all the way to your top function. That's the radius of your first function. Then you go from here to the line that's the equation of the second one. And when you subtract them out, you get the region. Another way you can think of this, again, is top to bottom. So if you're going around here, just like you did in area, top to bottom, this is your top curve and this is your bottom curve. So I'm going from negative 3 to 0. I put my pi. Now my top curve is this one. So that's my radius squared minus my bottom curve is x plus 6 squared. That's my height. And if you put it in your calculator in Math 9, you're going to get 48.6 pi. And I'm going to show you the calculator of that just so if you're having any problems with that. So here are our two functions that we were given. And we're going to graph. And so we're going to find our intersecting points. And just as we discussed before, that's 0, 6. We're going to find our other one. And so we have negative 3, 3. So now let's use our Math 9 feature. So we're going to do Math and pick number 9. And we're going from negative 3 to 0. Now you want to add parentheses because you're going to have to put a square. And we said our top curve was 6 minus 2x minus x squared. And we're going to close it off and put a square. And then we're going to subtract. And then we're going to put another parentheses, x plus 6. Square that, put our dx, so you can see how we type that. I don't usually put the pi, I usually just add that in the answer, because if you get an answer that they have it in terms in pi and you put pi in your calculator, then you're going to have to back it back out. So I just do that and then include the pi. So if I hit enter, I'm going to get 48.6. So as we said, that would be 48.6 pi. Now let's look at a washer example about the y-axis. We got y equal x squared plus 1, y equals 0, which is our x-axis, x equals 0, which is our y-axis, and x equals 1, which will be a vertical line. And we want to revolve around the y-axis. So we know that we are going to have to switch to x equations, so that's what I've done here. Solve the x. So when I go to use it, that'll be my x equation. And of course, these are already in x equations. Now, I'm going this way, so I need y bounds. But look, this one's a little bit different. So we're talking about this region in here. But when we go, this curve right here, which is your y, only starts at 0, 1. So think if I put a bold line right there. I can go from 1 to 2, and that'll be talking about that region. But what about this down here? Okay, this function doesn't even come into play here. So from 0 to 1, it's basically just x, the line here going around. So let me show you how we're going to do this. Okay, so I'm going to split it up, and I'm going to go from 0 to 1. Now, remember in your area, you're going right to left. So from 0 to 1, the only curve I have is what? X equals 1. That's my right curve, and it's going around x equals 0. So that's my right curve, that vertical line. That's my left curve. So from 0 to 1, I'm just doing x equals 1 squared minus 0 squared. X equals 1 squared minus 0 squared. So that's dy. Now when we come up to this section, we're going to go from 1 to 2. Now, what's our right curve? It's still x equals 1. What will our left curve now be? This right here. So we're going to do 1 squared minus, and then we're going to do this curve squared dy. Now, I've evaluated it doing it manually. You can check this out on your pass out, or you could do it Math 9 if it's a calculator. So remember, when you're going around the y-axis, you're using bounds that are y's, you're using x equal equations, and you're going from right to left.